and it'll give me another value. Imaginary 1 in front of the x, that's your a term. So negative 2 over 2 times 1. That equals negative 2 over 2, which equals negative 1. Now plugging this back in, negative 1 squared plus 2 times negative 1 plus 4. Simplified, that's 1 minus 2 plus 4. And that comes out to 3. So, here's our graph. So, this is our x-coordinate, and this is our y-coordinate. Negative 1, 3. And we have our vertex. Now we're going to make a table of values. Now we'll create a table of values. I'm going to use the points that are on one side of my axis of symmetry, which is here, simply for the fact that it's easier. I'm going to use negative 2, negative 3, negative 4, negative 5. Okay, now plugging these in, negative 2 squared plus 2 times negative 2 plus 4. So 4 minus 4 plus 4. That evens out to 4. Now, plugging in negative 3. Okay, so that equals out to 7. Now, negative 4. So 16, remember, negative times a negative equals a positive, minus 8 plus 4. And now finally, negative 5. Okay, now we're going to get these graphed. Now we're going to get these graphed. We have negative 2, 4. Because of the axis of symmetry, I can mirror that. Negative 3 and 7, again mirroring. Negative 4 and 12. Unfortunately, negative 4 and negative 5 go off of my graph paper. So we're just going to plot what we have, and you get this shape. However, because it does not intersect the x-axis at any point, this has no solution. Now for number 2, we're going to do it on the calculator. I'm going to clear the memory. Now, y equals x squared minus 4x minus 2. On the next line, y equals 0. Graph. You can already see here that it meets the x-axis. We just don't know where at this point. So now, second trace, 5. I can already see an area of the curve. So, yes. Enter. Second curve. Enter. I'm going to enter again. It tells me the intersection is about negative 0.5. That's one root. Negative 0.5. And I'm going to repeat that procedure. This time going to the other side. Enter again. Enter a third time. And here's another time where now it says our root is about 4.5. So in this situation, the roots are negative 0.5 and 4.5. Using graphing, you can solve any quadratic equation because all quadratic equations can be written out on a graph. However, if you have prime numbers, finding the vertex could get a little bit difficult. Here's another good one. Our third method is the quadratic formula. Remember, quadratic equation is written like this. So this equation right here, x equals negative b plus or minus the square root of b squared minus 4ac over 2a, will give you both of the roots to any quadratic equation. It will give you both because there are both positive and negative square roots. Now, the way you do this is you isolate all terms on one side, then set the equation equal to 0. Then substitute your values, your b value, your c value, your a value, into the quadratic formula and simplify it. But remember, you will eventually need to break it into negative b plus the square root of b squared minus 4ac over 2a and negative b minus, because a square root can be positive or negative. Now, here's some ones that we're going to solve.